Hello friends, my name is Mayank and welcome to my YouTube channel. In today's video, we are going to build something really exciting. A multi-document RAG knowledge base, and the best part, it runs completely locally, no API key, no cloud bills, zero data, leaving your machine. What exactly are we building? We are building a local privacy first AI chatbot that can answer questions from multiple documents simultaneously. You upload your PDF file, your reports, and you ask it anything in plain English. It reads all of them, find the relevant passages, and gives you an cited answer. The tech stack for this project is Olama running on local. We will choose what model we will choose. We will choose maybe Llama 3.2. That is the local LLM doing the actual answering generation. Numic embedded text for converting text chunks into semantics vector. ChromaDB as the persistent vector store. LangChain for orchestrate everything together. Streamlit for the web chat interface. Zero front-end coding required. And Lightning AI as the cloud environment, it has free CPU tier, which is perfect. By the end of this video, you will understand the complete architecture of the production grade rack system, and you will have a working application you can run yourself. Let us get into it. If you find this valuable, please like, share and subscribe with someone building AI apps, and subscribes to channel for more Azure AI, Azure OpenAI and Gen AI architecture contents. Let's go. What is RAG? Before we dive into the code and the architecture, let us make sure we all agree on what RAG actually is and why it matters. RAG stands for Retrieval Augmented Generation. The idea is simple but powerful. Instead of asking a language model question and hoping it has the answer baked into its training weight, which may be outdated or simply wrong, you give the model access to your document at query time. The model answers strictly from what is in those documents. Let me contrast this with the traditional approach. If you ask a plain LLM, say ChatGPT, with no attachment, what it refunds policy in your company's manual, it will answer based on its training data. It doesn't have your company manual. It might make something up. That is hallucination. And in business context, hallucination is not just annoying, it can be generally harmful. Now contrast that with a rack system. When you ask that same question, the system first retrieves the relevant passage from your actual company manual, then feeds those passages to LLM along with your question. The LLM reads those passages and generates an answer grounded in your real document, and it tells you exactly which page that answer came from. The key insight I want you to hold on this: if the answer is not in your document, RAG says so. It doesn't guess, it doesn't hallucinate, because the model is answering from receiving context, not from memory. This is fundamental shift that makes RAGs genuinely useful for real world application, legal compliance, HR, technical documentation, research, any domain where accuracy is non-negotiable. Technology stack. Let's walk through the technology stack we are using, and more importantly why we close each document. First, the LLM layer. We are using Olama to run Llama 3.2 locally. Llama is essentially a runtime that let you pull and run open source language model on your own machine or any server. The same way Docker runs containers, Llama 3.2 is a Meta's 3 billion parameter model, small enough to run on a CPU, good enough to give intelligent answer, and crucially zero API cost, zero data sharing. Second, embeddings, which we use Numic embed text, also running through Olama. This model converts text chunks into 768 dimensional semantic vector. When you ask a question, your question also get converted to vector. Then we find the document chunks whose vector are closest to your question vector. Those are the most relevant passages. Third, the vector database. We use ChromaDB. It is a lightweight open source vector store that runs locally on and persist on disk. Each document gets its own isolated collection in ChromaDB. I will explain why that design decision matters in few slides. Fourth, orchestration. We use LangChain. The LangChain expression language. This is what chain together to retrieval step, the prompt construction, and the LLM call into a clean composable pipeline. Fifth, the Streamlit. 2 dozen line of Python give you a full web chat interface. No HTML, no CSS, no JavaScript, just Python. And finally, platform, which will use Lightning AI. It gives us a cloud environment with a free CPU tier. You can spin up a studio, install everything, runs on app, and share the URL. And when you need GPU for faster inference, you switch to a T4 and switch back when done. All of those components run locally on or in your own Lightning AI environment. Nothing goes to OpenAI, nothing goes to any external service. This is what I mean by privacy first. Architecture, how it all connects. Now, let us look at the full architecture. I want you to understand how all these components connect before we touch any code. This system has two phases. Phase 1 is ingestion. This runs once you upload a document. Phase 2 is querying. This runs every time you ask question. Let me walk you through. Phase 1 ingestion. Step 1, the user upload a PDF document or a PDF or a document file. This file gets saved to the documents folder on the disk. Step 2, parse and chunk. The document is parsed to extract raw text. Then that text is split into chunks, 800 characters per chunk with 200 characters of overlap between consecutive chunks. The overlap is critical and it ensures that a sentence that sits at the boundary between two chunks is fully captured in at least one of them. Step 3, embed. Each chunk is sent to the Numic embed text model, which convert it into 768 dimensional semantic vector. Step 4, those stores along with original text and metadata like file name and page number are stored in ChromaDB. Each document get its own dedicated collection. That's ingestion done. The document is now searchable. Now phase 2. Every time the user asks a question, step 1, the user types a natural language question in the chat interface. Step 2, embed the query. That question is converted to vector using a same Numic embed text model. Same model, this is important. The query vector and document vectors must live in the same semantic space. Step 3, MMR. The system uses maximum marginal relevance to retrieve chunks. It fetches the top 20 candidate, then select the best 5 that are both relevant and diverse. I will explain MMR in detail in few slides. Step 4. Build the prompt. The 5 retrieved chunks, the conversation history, and the user questions are all injected into the prompt template. Step 5. LLM in generation. The answer. Llama 3.2 reads the prompt and generates a response citing the source document and page number. The entire pipeline runs in second on CPU. That is the full system.
Step by step setup on Lightning AI. Let us do the setup. I'm going to walk you through every step to get this running on Lightning AI from scratch. Step 1, creating a studio. Go to Lightning AI, signing in, go to my studio, click on new studio and select blank the CPU option. The CPU is a free tier. You don't need to select GPU for the setup and indexing. Only for inferencing, and even it is optional. Step 2, install Python dependencies in a terminal run. Pip install LangChain, LangCommunity, ChromaDB, PyPDF, Streamlit, LangChain, Olama. This installs everything. LangChain and its community integrates ChromaDB, PyPDF for parsing PDFs, Streamlit for the web UI, and LangChain Olama integration package. Step 3, install Olama. Run the official install script as curl command here. This install the Olama CLI and server. One command, no complexity. Step 4, pull models and start the Olama server. Run these three commands. Olama serve ampersand, Olama pull 3.2, Olama pull mnemonic embed text. The ampersand after Olama serves start it as a background process. Then we pull the two models we need, Olama 3.2 for generation and Numic embed text for embedding. This will take few minutes the first time as it download the model. Wait, verify Olama is running or not. Run this curl command. You should see the JSON response listing both models, Olama 3.2 and Numic embed text. If you see them, Olama is running correctly and both models are available. Step 6. Upload your app code and run it. Once you have uploaded your code or Python file from GitHub or you complete your code writing up your code, link is in the descriptions. I will give my this GitHub repository in the description. I will mention this. And you have to for the running this command you need to give that streamlit run app multifile.py server port 8080. Streamlit will start and give you a URL. Open it in your browser. You now have a running local RAG chatbot. Upload a PDF and start asking questions. So now I'm in Google browser opening Light. If you know about Lightning AI, if you want to see more about that Lightning AI, what is that Lightning, how it works, it basically it's a web browser based studio like if you have worked on Google Colab or any other browser type of editor, it is same. But however, it gives you GPUs, CPU. It is better than Google Colab because Google Colab you will only get the like a notebook running that. But however, here you will get a Visual Studio type of environment to running in. So in every month the pricing will basically you will get a $15 price for every month by default free of cost. However, if you want to go it for a more money, you can go for the pro teams and enterprise, and I think it's more than enough. If you are not using very much professionally, then it is fine. You can use it for $15 with the $0. So let me log in. Let me see how much money I have right now. It is logging in. I have logged in. Let go my. This is my dashboard. Currently, there are three I have using. One of 4 hours back, 2 months, 3 months back. I have used. Currently, I have $14.50 storage. I have 13.73 MB used only for but I have 200 GB. I think it's more than enough. Plan I'm on currently on a free plan. Billing is, I think, because I'm not. You don't need any mobile number or credit card before you want to start this Lightning AI. Let me go. So as per our steps, let us first go to click on New Studio. There are options: AI development, Python, Compify UI, Streamlit, Prep Data, Web App, machine learning. I think since we are using an Streamlit one, let me use this one, and it is a free CPU. If you want GPU as well, you can use for that as well. GPU option. This is the charge for cost per hour, and what is the time, and everything is the configuration it is given. GPU is, we don't need GPU because whenever we want we can switch to GPU. Let me start with CPU because until we will not set up everything done and we don't have anything running heavily, we don't need anything. I don't want to start it with this because I don't want to run it anything now new, or basically which I want to develop, by which these are the sample apps you can try. So now my basic environment has been ready. It is ready. There are options: what application preview, code, and I think this is restart, and this is open up in a new tab. So let me go to click on the code one. First thing, we need it to create a folder for our app because I don't want these files to go inside my repository in GitHub. So I have also need to connect this to my GitHub. So let me do that. I have opened my terminal. I see the path. Then I create one folder. I'll give my app name as multi doc o llama rag app. Let me also create an app in, is another way what we can do, we can create a app in GitHub and then we will clone it. I am in my profile. Let me create one. Go to create a repository, new repository. I'll give that repository name as multi-doc column rag app. Me add readme git ignore because we don't need the environment files to come inside it commit, and if there is any API key and other things which we don't have, create repository. Let me delete this folder. Now let me do the git clone this, but before that we have to connect and log into Git. Let me configure my Git here. So I'm trying to I'm configuring my Git in Lightning AI. I'm using GitHub and HTTPS. Authenticate Git with GitHub credentials. Yes, and then log in with web browser, then enter. It will open a page here in browser itself. Continue, click on continue. It's all done. Close it. Now I'm completely logged in with my GitHub. Now I can clone my GitHub here. This is my GitHub. So we have created our GitHub repository. We have logged into GitHub from Lightning AI as well. Now let me clone this to my GitHub repository to here in Lightning AI. For that, let me open another terminal, then go back to this, then GitHub CLI, copy this, run it here. Folder has been created. Now, for us, is we don't need to create a separate environment here in Lightning AI because it's one studio, it's equals to one app, and there is no need for me to create a separate environment. That separate environment is required when we have to execute multiple apps in a local system or in the same environment or same system. Here it's one system, one environment. I don't need to create. As well as we don't have a permission here in Lightning AI to just add or to do anything on this UV side, creating an environment here because this itself is the one environment. You can see it if I'll be able to show you. Ls minus ltra environment is already created and we are inside the environment. VS code and .venv also you can find it. It's already having all the environments ready system. There is no need for us to creating a separate environment here. Environment is already there. Surf and everything, dockers, everything is here. We don't need. Okay. Now for installing the libraries, there are two approaches. Either I can install one by one all the libraries, or else creating a requirement.txt file and just install it directly all the libraries. So let me go with the second approach, creating a requirement.txt file. I'll see it here. Okay, let me go inside it. Ls, my requirement.txt file is here. Let me put all the libraries. So I have added all the libraries, required libraries: LangChain, LangChain Community, LangChain Hugging Face, ChromaDB, PyPDF, unstructured for embedding and creating a chunks. Is transformer, sentence transformer. These are the basic libraries: Streamlit, Torch, LangChain, Chroma, and all these things are required. Let me install it. So let me install all the libraries. Okay, in it. Then all my required libraries will be installed. So now all the libraries has been installed, and we have completed step 1 and step 2 as per our document. Let me take you to our document. So we have created a studio in Lightning AI, installed all dependencies, Python dependencies. The rest of the steps: install Olama, pull model, and start Olama, verify Olama is running or not, or upload app and run. That we have to do. Start that. Now we have to install Olama. So let me open another terminal. Do that. So I have opened another terminal, and then I'm just installing Olama. First step. So Olama is installing. Then we have to pull models. There are other commands as well in Olama. You can check that. Olama installed. Let me check. Currently we don't have any model. Let me pull Olama 3 Llama 3.2. You can choose any other model. If you want to do it with any other gamma model or anything, you can do that. This will take some time. Llama 3.2 is done. Or do it for Mic model as well. This is also installed. Again, we'll check. You can see we have both the required models here. Go to start that server, Olama server. Our server start, Olama server starts. Let me verify. Next step, you can see that my server is also running. Now let us start and do the coding part for the rest of the app. Now let file called app underscore tipple.py. Due to some reason, I have deleted my old Lightning AI machine, and let me complete the rest of the setup again in this new setup again. And once it complete, we'll continue. So I have completed app multiple.py coding. So which in which we have which I have used Streamlit, Olama, LangChain, ChromaDB. Normally in the RAG demos, all documents are mixed into knowledge base. That's what we have discussed. That works when documents are from different domain. Retrieval can be also get noisy. So here is each upload file. It gets own collection that gives cleaner retrieval, better source. Let me open this application as well. So so far I have uploaded one document. Um, so I have to once I have uploaded the another document, I have to do some coding because I know which document I have uploaded, and I have to write the prompt as well. I'll show you in the code part. This is what I can inquire about this document. This document is of around 1,000 page. So it's as a POC purpose, it's more than enough, I think, to demonstrate. Another document is for operational manual vessel and container operations. Another document I will also upload. I can also upload 3 documents. I have coded for 3 documents here. The another third document is around 300 plus files pages file. Uh, Let me walk you through the code again. Back to code. Okay. So basically, cleaner retrieval, each better source traceability, and fix flexible mix and match query. So if I want only 2 out of 10 documents active, I just click one checkbox in the sidebar. Basically, if I currently I have only one document, if I have click only one, I'll click only for one. So one, if I'll have a one multiple files, I can click on the multiple files. Yes, let me. Okay, now we are on the top of this app multiple file. So on the top, basically, I define Olama base URL, LLM models, embed models, a document directory, chroma db directory. This you don't need to create, it will create when that you will upload the file, then it will train it and it will create the file. If suppose you will not, if there is a, you will upload another file which is not there, it will show the pedantic layer will stop that you to give any response, because it is not supposed that RAG's purpose is only to respond based on the queries or the documents which is being it was created. Okay, so basically for embedding, document and chroma storage basically for storage, and then chunk size and the chunk overlap, and finally we have a top k retrieval depth. I also defined supported type for this complete RAG model, RAG system. Supported type like PDF, TXT, Markdown, document, Excel or CSV, and images like JPG and PNG. That map also store icon, label, and whether the file is an image or what. Then it comes the smart embedding model. Basically, there there are useful helper resolve embedding model. Let me search that one. Resolve embedding model. It checks currently installed Olama model via API tags. If numeric embed text embedded model exists, it uses it. If not, it tries any model naming containing embed. If none exists, it raises a clear error telling us to pull an embedding model first. This avoids silent failure. So when you upload any file, it creates the meta.json.file as well. This app stores metadata in meta.json. For each upload, it tracks hash, path, collection time, file type. Using MD5 hashing, the app can tell if a file changed. If hash is unchanged, no need to reindex. That saves times and compute. Now come to multi-format loading and OCR part. Let me take you to the file. This function. Okay. Load file handles each file type with the right LangChain loader. PyPDF loader for PDF, text loader for text txt, unstructured markdown loader for MD files, doc to text loader for Word, CSV loader, and unstructured Excel loader for tabular files. For image, there is a OCR using Tesseract plus Pillow through extract text from image. If that is the function name, extract text from image. If OCR dependencies are missing, it returns a readable message instead of crashing. Now come to building part of that collections per file. Is the indexing pipeline flow. This is the indexing pipeline flow. Load file content. If non image split into chunks with recursive text character text splitter, create embedding using Olama embedding. Create chroma collection in .chromadb slash save collection name. Persist on disk. Each file is isolated by its own collection name from save collection name. Prompt engineering part, basically it's really important part is template. Let me take you to the templates. As I informed earlier that okay, for a specific file name, I can define custom behavior, assistant role, situation role, safety or compliance, safety or compliance reminder, fallback response when answer is missing, extra domain specific instructions. I so if I load a BMW manual, I can enforce spec situation behavior. If I upload IATA cargo doc, I can emphasize compliance terminology. If the file isn't it in the template registry, it fallbacks to default template. Then the build dynamic prompt for the selected file does one file prompt when one file is selected, merged multi-doc prompt when multiple files selected. So prompt behavior adapt dynamically to active scope. Let me take you to the another one next. So this is basically a building a chain. Builds the long LangChain chain for each selected file. Open corresponding chroma collection. Convert to retrieve the multi-model retrieval search. If one file is one file retrieves one if one retrieve exists, use it directly. If multiple, merge them with multi merge retriever. Chat Olama handles generation, prompt template applies domain rules, docs and formatted with source file and page number. Chain return answer and source document for explainability. Streamlit, the UI library, has two main zones: sidebar, file upload, auto index bar, file library and checkboxes, select all none, delete individual file and then and their collection to get toggles of showing source chunk and image preview. Olama health check with the available model list, clear chat and full reset buttons. Main area, app title and uses caption, POC warning, block describing in scope document, status bar for type and active selection. Optional selected image preview with OCR snippet, chat message with optional source and chunks expandable. When you submit the question, the user message is appended to a session state, app build chat history for recent turns, invokes chain and with question and chat history, receives answer plus source doc, duplicates human readable source like file name and plus page, shows timing chunks count and file count, stores assist response in session state. If anything falls, it shows a friendly error and reminder to start Olama. This architecture is practical because it gives modular indexing per file, fast re-indexing only when file changed, source level transparency, domain specific prompt rules, and clean UI for non technical user. It is especially useful for operations teams handling multiple SOPs, manual SOPs, manual and compliance documents. A multi collection RAG app with dynamic prompt source aware retrieval and practical document control in Streamlit. If you want how to add reranking, how to stream stream token response, and how to package for their production deployment. Let me take you to the PPT back. You can play. So I have questions. One of the question from the available questions. What are the key topics across all files? It gives me answer from the document itself. Message type. It's a basically IATA doc giving me answer properly. Okay, let me take you. Okay, now let's go to the next step. This all six steps has been completed. Now let me take you to the next step. So as we have, I have explained in the doc app multiple .py file. Let me explain on one more time. Most important architectural decision in this project why each document gets its own isolated chroma DB. A naive implement would put everything in one big vector database collection. You upload 10 documents, you have 10,000 chunks all mixed together. This creates a problem when you search for relevant chunks. The system treats all documents as one undifferentiated pool. You cannot easily add or remove individual document. You cannot tell a system only search document A and document B and document C. And if you want to delete a document, you have to either delete everything and reindex or implement complex metadata filtering. Our approach is different. Every document, manual A, manual B means one document, manual A, policy A, report C, gets its own chroma DB collection. The collection names is derived from the file with MD5 hash, which means if the file change, a new collection is created. If the file is unchanged, we reuse the existing collection. This is in incremental indexing built in. At a query time, the user selects which document to query using checkboxes in UI. The system instantiate retrieve only those selected collections. Then a merger retriever combines those retriever into a single undefined interface. Retrieval interface. LangChain runs MMR multi-model retrieval across all selected collections simultaneously, and the results are passed to LLM. This gives you four major benefits. One, you can add new document without touching existing one. Two, you can delete one document, only its collection is removed. Three, you can query any combination of documents as per your need. Four, ensures diverse results even when merging multiple resources. This is kind of the architecture decision that separates a prototype from something you would actually deploy in production. Okay, let me walk you through these six key features of the application. Feature 1, multi-file support. You can upload any combination of PDFs, documents, files, text, CSV and images. Each gets its own ChromaDB collection. As we just discussed, you can mix document type in a single session. File feature 2, MMR retrieval. Instead of plain similarity search, which often return near identical chunks, we are we use maximum marginal relevance. The configuration is fetch k equals 20, meaning we retrieve 20 candidate chunks and then select the best 5 that are that are both relevant and diverse. This prevent redundant chunks for polluting the context window and produce richer multi-agent answer. Feature 3, source citation. Each answer includes the source documentation, file name and page number. This is not optional. This is fundamental requirement for any trustworthy RAG system. If you cannot audit where an answer came from, you cannot trust it. Feature 4, incremental indexing. We complete an MD5 hash for of each uploaded file. If hash matches an existing ChromaDB collection, we skip read indexing. Only if the file has actually changed do we re-embed and restore. This means uploading the same document twice has zero computational cost. Feature 5, fully local and private. Zero data leaves your machine. No API keys, no cloud LLM billing. The model runs on Olama on your own hardware or in your own Lightning AI studio. This is what makes this systems viable and sensitive business document, legal, medical, financial, and HR data. Feature 6 shows retrieved chunks. There is a toggle in the UI that reveals the exact chunks used to generate each answer. This is a fully transparency. You can see precisely which context the LLM used, which helps you debug bad answer and tune your chunk size and retrieve parameters. One of the things I deliberately built it into the application is that all configuration lives at the top of app multiple py file. As named constant, you change a value of once and it propagates everywhere. So I have already discussed these Olama based URL LLM model while I was doing the code walkthrough. Let me give you again if you want. Let me do it once. So basically, Olama base URL default to this URL http localhost 11434. This is the Olama endpoint. If you are running Olama on a remote machine or a different port, change this one constant and everything works. LLM models basically default Olama 3.2. This is model used for answering answer generation. You can swap this to Mistral or better or Gamma any quality model and technical documents. Quinn 2.5 the best local quality if you have RAM. I will show a full model comparison in the next slide. Embed model basically numeric embed text. This is critical. The embedding model must match the one used in the to the indexed your document. If you change it, you must delete ChromaDB store and reindex everything. Chunk size is 800. This is control how large each text is. Smaller chunks gives you more precise retrieval but less context per chunk. Large chunks gives more context but may include irrelevant text. 800 is good starting point for most document type. Chunks overlap is 200. This is how much consecutive chunks overlap it prevents. Important information for failing it chunks boundary and being split across two multiple chunks. Top K is 5. This is how many chunks are sent to LLM or MMR selection. Increase this for complex question that requires more context, but be aware how more chunks mean more token and slower response. Document directories basically document where the files is uploaded from the storage in the disk. ChromaDB where ChromaDB persist its collection between sessions. You will notice that there are no OPI keys in the entire configuration. This is intentional. This is fully local system. MMR retrieval, why it matters. I want you I want to spend more time on the MMR because it is one of the most impactful quality improvement you can make it rack system and it is often undepreciated. Let me show the Let me show you the problem with plain similarity search using concrete example. Imagine your document is technical manual and heavily discussed a format called FWB, a freight booking message in IATA in our air cargo domain side. You ask explain FWB format, plain similarities, search, find the five chunks that are the most similar to your question. But five chunks might be all for from the same section of the manual, all talking about FWB structure. Just with slightly different wording, the LLM receives five near identical chunks and produce a narrow repetitive answer. Now look at the MMR. Does MMR maximize marginal relevance? Fetches 20 candidates chunks, but the selected top five that are both relevant and diverse from each other. The result chunks one covers the FWB structure Chunks 2 covers field definition. Chunk 3 shows an example message. Chunk 4 example explains the relationship with AWB. Chunk 5 gives booking context. 5 is genuinely different perspective on FWB. The LLM now produce a rich multi angle answer that covers the topic comprehensively. The more this matter more than almost any other configuration choice. A small amount of diversity in your retrieval chunks reduce dramatically better answer. The, con- the configuration for our steps setup is search type equal to mmr, fetch equals 20, the candidates retrieves from the chromodb, k equals to 5, the final chunks selected from mmr scoring and sent to the LLM. If you take one technical concept away from this video, let it be mmr. The switch from similarity to mmr and your RAG answer will immediately improve. One of the most common question I give is which model should I use? The answer depends on the three things: your available RAM, how much you care about speed versus quality, and whether you are using CPU or GPU. Let me walk you through the options. Phi 3 Mini at 3.8 billion parameters requires about 3 gigabyte of RAM. On CPU, it runs at 8 to 12 tokens per second. On T4 GPU, it hits 60 or more. Quality is good. This is great if quick testing and prototyping. Olama 3.2, 3 billion parameters requires about 4 gigabyte of RAM. Similar speed, 6 to 10 tokens per speed second. On CPU, 60 or more on T4 GPU. This is the default choice I have set in application. It is sweet spot of quality, speed and resources usage. I have marked it as recommended starting point. Mistral 7. I'm not going to discuss everything here. Let me know if you want something. I can discuss it about that. Or else I'll okay. Let me go to the next slide. Be completely honest about the current limitation of the system and then show how you upgrade if you want to take this toward production. Current limitation: first, CPU inference speed. On 7 million parameter model, you get 3 to 5 tokens per second on CPU. For 200 words answer, that is about 40 seconds of wait time. This is fine for personal use and demos, but not acceptable for in a user facing production application. This fixes GPU. Even a T4 improves this is to 40 to 50 token. I am not going to explain everything on this slide. So I have just highlighted the some highlighted point. For these things, if you want, I can create a separate video for that. So in the live DB, basically live application, It's what are all things we have used: Lightning AI, Chroma DB. I have to explain you that how you have to start your application in Lightning AI. So Lightning AI, you as a public URL, and in a, in you can switch from Lightning AI from CPU to GPU in a free tier, and how you have to do that. Let me explain these things to you. The rest of the features I have already discussed. So let me come back to you on the application side first. So this is our application, and if you want to switch to CPU to GPU, you have in the right corner you can find the CPU. You have to just click and then choose the GPU. When you choose the GPU, you have to just uh, it will switch, but you may need to restart the application. Here at the right hand side, you can find that you can add in the web app. You can find that Streamlit. You have to install it. This one, if you remove it, it remove. However, it is not so mandatory. So better if you add it. So once you will add, you will get the option to get a public URL. So if you will get it, so let me take you a start. One second, let me see that if the application is running currently or what is that state. Currently application is not running. So let me go and start the application. This will go away. This will again come back. Okay. So by this way you can share it this with any with any of the users. So you can get this public link, and then you can copy this public link here. It is same Lightning AI. Just paste it again. It will not change, but you can take it again. If you leave it for some idle time, it will change it. Maybe because of some restart there could be a issue, but this is the way you can start your application. Otherwise you can after having this Streamlit, you can have this URL with you, and uh, this URL this URL, and you can start it locally as well. Like let me show you that one as well. This you can copy, and you can go to your application, open another one, another terminal, and just paste it and enter it. So your server will start. Now the server starts, and then you can do the same thing again here. Let's see if it's gone. Okay, these errors. Olama is not running. Why Olama is not running? Because it's whenever it's restart and you leave it idle, then the Olama will stop. So you need to do. I have already copied all these documents here. Steps. You have to install Olama, and then you have to start that. Let me do that quickly. Now I have installed Olama again, and my application is Olama is also running. Let me start that server again. Streamlit. Yes, start. Public URL is still there, but it will not work. Once this will start, it will start working. Okay, it started, and now if I'll click it again, it is working. Should work. Yes, it is working. So this is all about, and let me take you to my last slide of the this one. Oops. So please, if you like my video, please like, share, and subscribe. Drop a comments, and I'll also leave my GitHub link for this application. I'll commit the code and I'll share it with you. And yes, thank you for watching. Thank you for watching. Thank you.